Okay, we're going to talk about transformation of functions. In our basic function form, if we think we have three different numbers that contribute to our transformation. The first is the a value, which is this value of the in front of the grouping symbol, so in the front of your function. And a has a couple different purposes. The first is if the a value is greater than 1, it is going to stretch the graph vertically. In other words, it makes it narrower. If a has a value that is between 0 and 1, then it's going to compress the graph vertically. And then if a is a number that is less than 1, in other words, or less than 0, sorry. In other words, it's a negative value, then it reflects the graph over the x-axis. So that's what a does to the graph. If you have a value inside the grouping symbol, this is operations performed on the x value inside the grouping symbol, then this value is going to do horizontal transformations. It's going to change the x value because it's grouped with the x. It's going to happen as effect on the x. Okay, so horizontal transformations. If it shows as x plus c, this graph is going to move left c units. If it's x minus c, it's going to move right c units. And it may seem strange because you think, well, plus means right, positive, left, negative. But the original equation is always x minus c. So if it's a minus a negative c, that's where you get the plus. So x minus negative c. So that's why it's plus to go left. The c is negative left. And then if you do x minus a positive c, that's where you get the x minus c. C is positive, which is why you go right. And the last part is a transformation of the function with adding or subtracting. Now this function is equal to y, so when you add d, you're adding the value to the y. So this is going to be a vertical transformation. Okay? If d is greater than 0, you're going to go up d units. If d is less than 0, you're going to go down d units. So let's see how we can apply this to actually graphing a example. So here's an example. We have a equals 2. The c value is 1. And the d value is 4. So we always want to think about our transformation side to side. A normal graph starts at 0, 0. That's the parent function. So we're going to go, c is horizontal. Since it's 1 unit positive, it's going to go right 1. And then d is vertical, so up 4. So that is our new vertex, our starting point of our absolute value function. The normal absolute value function is going to be a v that goes up 1 over 1. Okay, so we're going to have our new vertex. It's not going to be at 0, 0. It's going to be at 1, 4. And our new a is going to take every point and multiply by 2. So instead of the y value being 1, it's going to go 2. So it can kind of think of it as a slope because it's linear. It's going to go up 2 and over 1 instead. And this is the new graph. So the graph of y equals 2 times the absolute value of x minus 1 plus 4 is here. Shifted 1 to the right, up 4, slope of 2, and you have your graph.